Friends, in this video, I'm going to explain about the distribution of the toric IOL power in terms of spherical equivalency as well as the cylinder power in the IOL optic. So here you can see there is this lens, this toric lens, with a spherical equivalent of 22.5 diopters and a cylinder power of 3 diopters of cylinder power, right? That's a T5 model. Now, how is this power distributed in the toric lens, right? Now, to understand this, we need to have a basic understanding of spherical equivalency. So, what is spherical equivalency, or AC, is equal to sphere power, the sphere power, plus half of the cylinder power, right? Half of the cylinder power. Now, spherical equivalency here is 22.50, right? 22.50. We do not know the sphere power. And then plus half of the cylinder power. We know the cylinder power over here, that is 3 diopters, right? 3 diopters. Half of 3 diopters is how much? 1.5 diopters. So the spherical power in this IOL, the spherical power will be 22.50 minus 1.5 diopters, which is 21 diopters, right? So how will this power be distributed? This 21 diopter will go in the optic-haptic junction axis, right? We know that the flat meridian of the lens is in the optic-haptic junction. That is where you have these dot marks in these lenses. So 21 diopter will be in the optic-haptic axis, optic-haptic junction axis. And 90 degree away from there, let us find out what would be the steep power, what would be the power in the steep meridian. Now, the steep meridian will have a power of, you can find it in 2 ways. Either you got the flat meridian power, 21 diopter, add the 3 diopter cylinder over here. So 21 plus 3 diopters will be 24 diopters. Or you can also add on 22.5, which is the spherical equivalency, 22.5 plus half of the cylinder power. Either way you can do it, they will come to 24 diopters. Both will come to 24 diopters. So 24 diopters in this case will be on this steep meridian. This is how the distribution of the IOL spherical equivalency and the toric model looks like in the IOL plane. Well, let us now look into the second example. In the second example, we have 21.50 as the spherical equivalent. The cylinder is 0.75. Well, the sphere power will be spherical equivalent minus half of the cylinder, right? It's the same equation. I just wrote in a different way because you are trying to find the sphere power here. So the spherical equivalent is 21.50 minus half of the cylinder, which is 0.75. This is 0.375. Half of 0.75 is 0.375. So the sphere power will be 21.50 minus 0.375, which is around 21.125, right? 21. So this is the power in the flat meridian of the lens. In the flat meridian, which is the optic-haptic junction, 21.125 will be the power. And you can see this is what is actually also mentioned in the box of this lens. Not many manufacturers mention this spherical power, but that is what is mentioned here, and this goes into the flat axis of the lens. Now, how do you find out the steep meridian power? You can either add the cylinder value over here. The cylinder is 0.75. So just add 0.75 diopter of cylinder. Or if you want to add on the spherical equivalent, then 21.50 plus the half of the cylinder, 0.375. Either way, you will get to the power of the steep meridian here. 21.125 plus 0.75 diopters is 21.875. Now, you will also get the same value over here. For example, 21.50 plus half of the cylinder, which is 0.375, is also 21.875. So this is the power in the steep meridian here. 21.875 will be the power in the steep meridian here. So now let's look into these two situations over here. In this company calculator, you have option 1, the surgeon can implant a T4 lens, or the surgeon can also implant a T5 lens. Of course, the residual astigmatism will change accordingly, right? Now, what happens, the purpose of this video is to show you what changes in the IOL power when you move from a T4 model to a T5 model, right? Without changing the spherical equivalency. The spherical equivalency is the same in both the lenses, right? Now, we know that T4 corrects 2.25 diopters, and half of that is 1.125 diopters. That is important, right? So, sphere power, that is the sphere power in the power in the flat meridian of the lens, will be 10 diopters minus, which is the spherical equivalency, 10 diopters minus 1.125, which is 8.87, right? And the power on the steep meridian will be then either 8.87 plus 2.25 diopters. You can do that because that's the cylinder power. Or you can also do 10 diopters plus half of this, 1.125. Either way, it's the same. And that will come to 11.125. So that would be the power in the steep meridian here. This is the power in the flat meridian here, right? Now let's look into the T5 model. Corrects 3 diopters on the corneal plane. Half of that is 1.5 diopters. So the power on the flat meridian, the power in the flat meridian will be, the power in the flat meridian, will be 10 diopters, which is the spherical equivalency, minus 1.5 diopters, which is 8.5 diopters. So the flat meridian will have a power of 8.5 diopters, and 90 degree away from there, the power in the steep meridian will be again 8.5 plus 3 diopters, or you can also do 10 diopters plus half of the cylinder value, which is 1.5 diopters. Either way, it would be the same, 11.50. So this is how it compares. Right? A T5 will have 8.5 diopters in the flat axis of the lens compared to 8.87 diopters or 8.9 diopters as a round value in the flat axis of the lens, right? So compared to the T4, the T5 will have less power in the flat axis. But in the steep meridian of the T5, it will have 11.5 compared to the 11.125 of the T4 in the steep meridian. So it will have more power, of course, needless to say. While the flat meridian will have less power, the steep meridian will be having more power of the T5 model compared to the T4 model, right?